Right, it's time to put the hands on performance robots. These are a pair of robots I built, and the full build series is in the channel. Each one has 6 brushless motors, 4 brushed motors, 3 servos and a bunch of LEDs in it. It's made of welded steel, CNC aluminium and 3D printing. So I've got puppeteering rigs which I can control the robots with, and when you move the little puppet then the robot moves, and I made 2 puppeteering rigs and of course 2 robots. But the robots have never had hands, so as well as being able to control the robots with DMX lighting software to script up a show, we can also of course manually control them, and the long-term plan was we could use these for collaborations and challenges where each person controls a robot and they have to complete a task. So these are my puppeteering rigs. We've got 2 of these and I've installed a switch here. There's going to be one on the other arm as well, and that switch of course is going to be for gripping, and it is just a simple switch which is going to close the gripper, so that's pretty easy to implement. However, of course, what we need to do is apply an equal amount of tension to whatever we grip, no matter how big it is. So I could just use a servo on a spring, but obviously if the jaw of the grippers is right out here, then that spring is going to get stretched a lot as the servo pulls it, and if it's right in here, it hardly gets stretched at all. And that'll apply different amounts of tension, which means it won't grip things which are smaller as well as things which are big. This video isn't sponsored, but this is just a quick ad for ways you can support the channel, and that makes all the difference to the projects. I have Patreon and YouTube channel membership where you can get access to all my videos up to a week early and sneak peeks and pictures of what's coming up and be part of that discussion. I have some affiliate links in the description which include a free trial sign up for Skillshare, Matter Hackers 3D printing supplies, my Amazon affiliate link, and Epidemic Sound. And Epidemic Sound is the service where I get all the music for my videos. I also of course have my merchandise store where you can get t-shirts, bags, socks and various other merchandise with pictures of some of the things I've made on. Right, let's get back to those hands. So we're actually going to build quite a simple robot gripper just with 2 fingers like that which can open and close. I was going to build a proper hand with 4 fingers on one side and effectively the thumb on the other, but I think actually this will be easier to pinpoint objects to pick them up to do challenges. The whole thing is going to rotate, so the wrist will have this rotation axis that's already built into the puppeteering rig, but then of course we've got the gripper and the way of applying tension that's always constant. So in the middle we've got a very special mechanism. First of all, this part slides of course to open and shut the jaws of the gripper. We've also got another piece inside there, and that piece slides independently, and those 2 pieces are going to be sprung together. It's quite complicated to explain, so let's have a look at it in real life. So I've printed my fingers and I've printed the internal, and of course we've got this slider here that goes up and down, and when those fingers are installed of course they fit on just like that, and that will nicely open and close them. Of course we need to put some bolts in here to pivot them. Inside here though is the other sliding mechanism, and you can maybe see there's a black part, and if I stretch this out I've already installed the spring, which hopefully you can see between the 2 parts there. That means this thing springs back in place. And I've installed a magnet in here that's glued in, and we're going to put a Hall effect sensor in that gap so that we can measure the gap, and then we'll pull this with a servo until we always get a tension or a gap that's the same size. And that means no matter wherever the jaw's shut, this gap will always be a certain size when we stop the servo, and that means we can always pull the same amount of tension. So I've installed my fingers there, which seem to work pretty well, and now of course no matter where they get stuck on whatever we're picking up, we can pull this back till we get a certain amount of tension, and this gap is a certain size, and that will always mean the servo pulls the right amount of tension. We don't overstrain the servo stretching a massive spring, and it's the same down here with the same amount of tension on the spring. So we've made everything 4 times, so we've got 4 grippers, 2 in yellow and 2 in blue, so we've got 2 hands and we've got 2 robots, and these are all the other parts to make up the rest of the arm. So my Hall effect sensor is fitted in there next to the magnet, and we've also got this servo lever that pulls this mechanism and pulls the Hall effect sensor away from the magnet, and of course that also operates the whole arm. That of course plugs into the rest of the forearm that I've now assembled out of multiple parts, and we have a servo in here which fits onto the servo horn that's fitted on here. So hopefully you can see that servo's fitted in there, and it's got a lever that now pulls that spring mechanism and operates the hand, and we've got the other servo fitted in the back so this whole thing can turn. As it turns, all the wires run through a curved channel there, and that runs out of the back and then through again into the enclosure for the electronics on the bottom. So we've got our electronics installed there, which is built on a lovely piece of proto board with some lovely neat soldering on the back, and on there we have an Arduino Nano and a Max 485 adapter to read RS485 because we're going to control this as a DMX node like the rest of the robot. So that's just plugged into USB at the moment. We've got places to attach our servos. I've only attached the one for the gripper, the other one isn't attached, and we also have a 5-volt power supply just powering this at the moment. Eventually that power will come from the main power supply for the robot. So hopefully you can see that we've got the Hall effect sensor sticking out here at the moment, we've got the jaws fully open, and we've got the servo in here that's pulling them shut. On the terminal we've got three things. We've got the mode I'm in, which is basically just a serial test for now. Eventually we'll read over DMX, but for now there's the modes for opening and shutting the gripper. We've got the Hall effect sensor, which is the second column there, and we've also got the actual servo position, which is the third column. So now if I go and shut the jaws, we'll go into mode 1, and you can see that servo running all the way through to 180 and closing, and you can see the Hall effect sensor still 0 because we haven't stretched the spring, but if I pull the jaws apart, we can see we get lots of lovely values there. Now I've set the jaw to close only if the value on the Hall effect sensor is bigger than -300. So let's open those jaws again, and now let's go and block the jaws here. So I'm going to go and close the gripper again, and we should see that that servo only moves partially because the Hall effect sensor's gone to -326. And if I pull this a little bit more, we can see the servo moves a little bit more until it pulls a spring, and again and again. And so that means we can always apply the right amount of tension to the item that we're gripping in there without over-constraining or overstraining this servo and overstraining that spring. And the way I've done that is basically if the flag is 1, which is the mode that I'm just reading in with some serial reads up here with an A or a B, then we basically go and add 1 to that hand value every time the loop comes round, which runs 100 times a second until we get to 180. And we only do that while the Hall effect sensor is bigger than -300. If we put it in the other mode, it just opens the hand again. So now I'm using that Max 485 transceiver to receive RS485 data, or more accurately the DMX data from my puppeteering rig. So now I can control the 2 axes in the arm there. So if I move the arm this way on my puppeteering rig, you should be able to see that rotating the robot's wrist. And of course if I grip the switch, we now close the gripper, and that means that I can pick things up. And of course the rest of the axes in here are already in the robot. Alright.
Yeah.
Hello.
Right.
So what we've got is a puppeteering rig.
Yeah.
Which is like a little robot.
Yes.
If you grab the handles,
yeah,
you should be able to move your robot arms all around. So you've got axes that move this way, and elbows, yeah, and rotating the wrists. And you should find 2 little switches that grip the grippers.
Okay.
Good, good.
Wow.
And you can also lean forward by pushing the whole thing forward at the waist.
Yeah.
And back, of course, if you need to. I'm surprised.
Okay, yes.
And also side to side, so you can reach.
Well, it looks like I can also tear you apart if I
Yeah,
really
we have to be
wanted
quite careful not to trash each other, and you can also knock the robots' heads off if you're...
Okay. Ooh, gonna watch where you are. Nice.
Good, right, let's do a robot challenge.
Okay. Yeah.
Challenge is to get the balls in the box, and
Yep.
it's over when all the balls have gone off the stalks.
But it's going to be all over the floor then, isn't
Yeah.
it? But hey,
So we might need to move them slightly because
I think.
we need to move them forward slightly.
Well, I don't know actually. I'm kind of. I think the
You're
key
right.
is to do one at a time. I'm going to use with the body.
All right.
Come on. Oh no, so close. No, don't go. No. That was so close. Here we go. Number 2. Oh God.
Oh, that didn't go there.
No, no, no. No! I've been so close to getting that one now. Come on. Number 3. Number 3.
Oh no, I haven't got any.
I'm homing in. Just tell you what's tricky is
You
like.
should just lean forward and back for my new.
Come on! Come on!
no.
Oh, I've got one. Right, hang on. Into the box. Here we go. Without knocking that one off.
Have you got any in yet?
No, I've only just picked up
down.
one. Hang on a minute. I can't actually get it into
I need to lean sideways slightly.
I can't. I can't. My box. Hang on a minute. I am not giving up. Now I've got one. There's no way I'm not getting this in the box. I think the problem is I can't get my elbow back any further. Can I? I can't get the shoulder back any further.
Maybe we should move the box in a minute. Maybe pull forwards or something.
Right. I'm just going to hold on to that for now. I'm going to go with my left arm and try and get one from here. Hang on. This is going to get super complicated now because I just don't want to drop that one over there. Right, hang on, let's come back like that. No, not that way. Why is this? What? Hang on. Right, I've got two.
Can you put them in the box?
Now, here we go. I think this one.
Lost.
Here we go. Lean back a bit.
I'm going to rotate and fix your arm.
Hang on a minute. Come on, I've got to get this. I think if I roll it that way and then bring it over that way, will it drop over the back or the front? Ah! So close. I don't think I can actually get that one anywhere near.
We need to move the box.
I think we need to move.
Maybe we need the box in the middle, and we need to then turn those round.
Yeah. Okay.
Right.
But I think it's fair to say that I won that one.
Have you got any in?
Well. Only I picked one up.
You've still got two on there.
Yeah,
Hasn't
you
finished
haven't
yet.
even picked one up.
I did pick one up, but then it fell down.
Oh, come on. I think that's a clear win.
Move
for
the
me.
box.
This is going to be a really long edit. What about if I put it back on there? Does that win a point?
Oh, I guess so. If you're dexterous enough to put it on that tube,
Okay.
it's hard enough to do with my own hands.
If I can get it on a tube, I think I win this round. Hang on. Years of puppeteering.
Oh, come on.
Years of puppeteering, that's what that is. Thank you. I mean, you know, different kettle of fish. It's kind of tricky getting to this one, though, isn't it?
I don't think my box is in the middle. Oh!
Well, I put it somewhere where it felt like it was going to be most useful. Oh, no. I mean, you can get the arms over the box on this one, it's much easier. Oh, no.
Oh, well, there's one in my box.
You're hammering through them, that's for sure. Come on, one left. What's it going to be, a left arm or a right arm one, this one? It's a bit tricky to get to, this one. Now you're just destroying everything. Come on. Five!
Oh, right, celebration.
Celebration without destroying each other.
First of all, a big thanks to Matt for helping me out with the challenge. He didn't get shot in the eye this time, which is good. Check out his channel for 2-ton hydraulic walking robots, giant 3D printed Lego and Star Wars droids and lots of other stuff. So I think I need to work on the challenge a bit, work out where to put the box and the tubes and that sort of thing, or work out whether we in fact stack up blocks or something like that, but hopefully you get the idea. And it's not too hard to operate, probably takes a bit of practice, so it's for special people only. Performance robots are available for events. I've already done a few events with the robots at the moment, and I'm available for bookings in the UK if you want them for some sort of event, a science festival, something like that. We've got scripted performances, accessible interfaces for the robots as well, which can be operated by anyone, and of course puppeteering challenges, so get in touch if you'd like to see me somewhere. Alright, that's all for now.